Assalamualaikum and hi everyone. This is the first part of chapter 1. Okay, this is actually the introduction to the whole course of signal and system. So for this part, I'm going to explain to you on the types of signal. Okay, this is actually the outline for the whole chapter. Okay, so for today, I'm going to talk about the introduction and also types of signal. Okay, the course of signals and system is actually about the signals and also how to process the signals by the system. So basically, it involves modeling of physical signals by mathematical functions. Okay, meaning that you model that signal. Okay, because you can't see the signal, right? So using this course, we can actually represent the signal using the mathematical functions. And another one is also involves modeling of physical systems by mathematical equations. Um, when we say the system, it can be anything. Again, after this, I'm going to show you some examples of the system. So we are going to represent that system in terms of mathematical equations, and also it involves solutions of the equations when excited by the functions. Okay, it means when it is triggered by the functions. So the reason why we study signals and systems is because this course serves as fundamental to all engineering courses. Okay, when we talk about engineering, normally in engineering, when we want to build something, okay, the first thing we will do is actually model the system. Okay, model means we represent the system in terms of mathematical description. So it involves writing a mathematical description of input and output signals. Okay, this is when we are talking about system. And then after we model the system, we we analyze the system. Okay, we analyze the system. We study the various signals associated with the system. Okay, we can actually say the system in terms of let me show you here. Okay, we can actually put the system like this in terms of a box. This is a input signal and this is an output signal. Okay, so the analysis of the system is also done using our knowledge in signal system. So it involves study of the various signals associated with the system, and next we design the system. After we are satisfied with the analysis of the system, we want to design the system. Okay, we need to decide on a suitable system architecture, and we need also to find suitable system parameters. Okay, so after we design, we want to implement the system. Okay, before we implement it in real life, we want to implement and test the system. So we need to check the system and the input output signals, and to see that the performance is satisfactory. Okay, maybe we set a certain level of performance. For example, the system have to achieve like certain accuracy, okay, or certain precision. Then only we can commercialize the system or release the system to be used by others. All right, now what is actually signal? Okay, so if you see, if you think logically, we cannot see any signals using our own eyes. Okay, but we can see the analysis of the signals. Okay, basically, it is any physical, it is any physical time varying quantities that carry certain information. Okay, it has to carry the information. Okay, it is something that represents information, and our world is full of signals, both natural and man-made. Okay, so the keyword here is a physical quantity. Okay, physical time varying quantities. It means that the signal varies with time. Okay, it will change with times. Okay, varies with time and also carry information. Okay, and for example, the temperature at designated point in particular room. Okay, this is also we call a signal. This signal is a function of time since the temperature varies with time. Okay, and then another examples are human voice. Okay, my voice is a signal. You can hear it, but you cannot see it, right? Baby's crying. Okay, the value of stock market. Okay, radio signal, video signal, or voltage waveform in a circuit is also called signal. Okay, and for a system, it is actually a signal processor that can either modify the signal or extracts further information from the received signal. Okay, in other words, it is a generator of signals or it is a transformer of signals. So remember what that I draw just now. Okay, so this we can say it represents system. Then there will be input signals. Okay, it can be more than one input signals, and there will be output signals. It can also be more than one output signals. Okay, so this system here, okay, it can be the generator of signals. It means using the input of the signal, it can generate new signal, or it transform an input signal here. Okay, so it can be generator of signals or transformer of signals. So for example, a human body. Okay, we are also a system. Okay, we listen to the input. You are now listening to the input signals from my output signal. Okay, so I'm giving you an output signal, okay, output signal from my system, which is my human body, and currently you are listening to my input to my signals. Okay, so these signals become input signal to you. Okay, and it goes through your ears, okay, and also your body, your mind, okay, will interpret the signals or will analyze the signal. Okay, another one is a radio receiver, and also a software algorithm can also be a system where it receives input signals and also transform or generate a new signals. A system can have one or multiple input ports, like I said before. It can be more than one um, port and also one or multiple output ports. Okay, sorry, let me erase this one. Okay, you can see the system here. Okay, you can see the system. This is an input or excitation signal. It goes through the system, and it can be like output or a new signal or response signal to the input signals. Okay, another example is electric circuit, where the voltage is actually the input signal and current is actually the output signal. Okay, now as we go to the types of signal. Okay, we have different type of signal. Okay, so we will look one by one. This is basically a type of signal and actually the opposite type of signal. For example, continuous and also discrete, analog and digital, and so on. Okay, for continuous and discrete signals, okay, first we look at the continuous signals. When I say continuous, it means that this signal has certain values at every single time t. Okay, as small as 0, for example, 0.11111114, for example, okay, which we cannot see clearly in the graph here. And at 0.111114, we still have signals. We have signal. Okay, at every single point we have signals. Okay, for example, telephone output and video camera. So this is continuous. It always has values at every single time. Okay, maksudnya dia ada value dekat semua time. For discrete signals, okay, these signals have certain values defined at certain instance of time, t. Okay, for example here, this is time t. Okay, this graph, okay, only have signals at 0.1, okay, 0.1, 0.2, 0.3, 0.4, 0.5, and so on. So in between 0.1 and 0.2, let's say here, which is 0.1515, there is no signal at all. Okay, it means that the signal only, there is only signals at certain time. Okay, certain time, and the time interval for this example is 0.1. Time interval means the interval, okay, or the duration between another signal. Okay, so from 0.6 here to 0.7, the gap here is 0.1. So that is the interval. Okay, for example, here is total monthly sale for a company and also average daily stock market. It's also considered as discrete signal. Okay, and the next one is analog signal. Okay, a signal with amplitude which can take any values in a continuous range. This is what we call analog signal. Okay, sorry, we have the example after this. So analog signal, amplitude of analog signal can be of infinite value. Okay, so after this, we are going to see the example of analog signal. So for analog signal, the signal with amplitude, it can take any values in the continuous range. But for digital signal, signal can have amplitude with certain value only. We already determine the certain value of digital signal. So the easiest one is 0101. That is a digital signal. So for analog signal, it can has amplitude um, uh, as small as 0.11114 or as big as like 9.99.9999. Okay, so this is analog signal. It can have values at any time. Okay, this is analog and also continuous time. Okay, for the digital signal, it is we call it, the amplitude is distinct. We can see like maybe -1 and 1 and so on. So that is digital signal. Okay, this is examples of different types of signal. Okay, first we look at the analog signal and also time continuous. So as we can see here, these signals has values at every single time t here. Okay, at every single time t here, the signals has values. Okay, and also this signal has values at all the amplitude here. Okay, it means that it can be if we put if we sample here. Okay, this signal it has values here. Okay, and it has different values here. It has different values here. Okay, so that is what we call analog signal. Okay, but for digital signal and time continuous, if we see the difference here, it has values at all time t. Okay, it has values at all time t, but the values is either, okay, it can be 1 or -1. So the values can be 1 or only -1. Okay, this is only example. If you want to put 5, then you can put 5. Okay, so it has only two values here. Okay, at every single time. So that is digital signal and time continuous. Okay, another one is analog signal and time discrete. Okay, if we see this example here, the time is discrete because there is no signal in between these two lines, for example. Okay, there is no signal here, there is no signal here. Okay, so it means that the time is discrete. However, the values amplitude can be varied, not only two values like digital signal. So that is analog signal and time discrete. Another example is digital signal and time discrete. Okay, so this is totally digital. Okay, and the values can be, for example, if you put like 10 and -10, it can be like two values only, right? And the time also discrete. It means that there is no signal in between the interval of this line. Okay, so that is digital signal and time discrete. Okay, the next one, we look at the energy and also power signals. When we say energy signals, these signals has certain value of energy. When you see like the graph of any signal, and for example, that signal is always flat, and somehow it peak at any certain time here. It peak at any certain time here. So this is what we call energy signal. And energy can be determined by the formula like this. Okay, it means that we integrate from negative infinity to infinity the amplitude of the signal, and also we square that. Okay, we square the ft. Okay, and we can get the energy of the signals. Okay, this is the example. Okay, the signal with the energy. On the contrary, for the power signal, it has certain value of power and non-zero energy. Okay, why does this power signal has non-zero energy? Because it has many peak. Okay, it's not like um, if you say like calm and then somehow it has peak. It's not like that. Okay, the power always has energy, and it can be derived from this formula using integration from limit t towards 0, 1 over t, and integrate from negative t over 2 to t over 2 f squared t. So t here is actually a duration of the signal. Okay, so this is an example of power signal. Okay, so you should take note of this. Power is actually a time average factor of energy. Okay, because this is how we find the power signal. Okay, sorry, the signal of the power. So actually it's almost the same formula with energy signal, but we divide with the t. Okay, which is actually the average factor of energy. Okay, energy signal has a certain or finite value of energy. Okay, it cannot be unlimited. Okay, it has a finite value of energy and has zero value of power. Okay, it means it has zero power, but power signal has certain value of power. Okay, it means it has values in terms of power and has infinite value of energy. Okay, as you can see from the previous graph here, it has energy. Okay, it has unlimited or infinite value of energy. And in general, the signal that has certain value in time from negative infinity to positive infinity has infinite energy, and this is called power signal. Okay, because it has values in time from negative infinity to infinity. So this is what we call infinite energy or power signal. Okay, if you see the examples here, okay, it always has the values at every single time. Okay, and a signal cannot possess both properties of energy and power simultaneously, but it can possess neither. Okay, it means that it can be not an energy or power signal, but it cannot be both energy and also power signal. Okay, okay. One example of power signal. Okay, one example of power signal where it always has values at any time is what we call wave at the beach. Okay, at the ocean, wave. It always has values. So that is what we call a power signal. Okay. And the next one is harmonic signal. So harmonic signal is also known as periodic signal. Okay, periodic means berkala in Malay. So another name for periodic is harmonic. So in the exam or test, when you are asked about harmonic signal, so you need to know it's actually means the same as periodic signal or periodical signal. Okay, so condition for harmonic signal ft for any value of positive t, it has to fulfill this condition. Ft is equal to ft plus capital T. So T here means the current time, and the capital T here means the duration of the signal. So it is also need to be equal to ft plus nt. So n can be any integer. So when we say about t, okay, the simplest example here is the sine wave. Okay, sine wave is like this. Okay, so what is t? T is one duration of full cycle of the signal. So this is actually, oh sorry, not until this. Okay, until this. Okay, this is what we call t. Okay, when we represent the signal as ft, so t, the small t here means at any time t here. Okay, and the capital T here is the duration of the signal. Okay, and n is any integer, means that the duration here must always be same with this duration here, and so on. Okay, and also when we say like ft is equal to ft plus t equal to ft plus nt. Okay, a simple example here is if we take the point here, okay, it has to be the amplitude here has to be the same as another point in another duration here, in the first duration. And if n is equal to 2, then that means it should be here. Okay, so the value of the amplitude here must be the same, right? And minimum value for t is known as the fundamental period t naught. Okay, so you will learn more about t naught here in the Fourier series chapter. Okay, so t here can be different because when we talk about the harmonic signal, the duration here can be like become bigger and bigger. So the minimum value for t here is known as t naught. So t naught is the smallest duration, or we call it the fundamental period. Okay, and fundamental frequency is actually inverse with t naught, so f naught is equal to 1 over t naught. So this is the basic formula that you need to remember and memorize. Okay, this is very basic, this is fundamental. If you don't know this, then you are in big trouble. And omega naught is angular frequency. Omega naught is what we call is angular frequency. Okay, so angular frequency is equal to 2 pi f naught. So remember that 2 pi f naught. So it's also equal to 2 pi over t naught if you replace f naught with 1 over t naught. Alright? Okay, oops, sorry. So in order for me to show the example here, I need to erase this back. Okay, so the example here. Okay, this is the example here. Okay, this is the harmonic signal. This is 1 t naught. Okay, for the triangle signal. Okay, 1 t naught before another signal repeat itself again. And this is t naught. Okay, for sine wave, but the shape is rectangle signal. Okay, this is 1 t naught. This is another t naught, and so on. Okay, and for non-harmonic signal, the signal does not repeat itself. Okay, it has only one value like this. So this is what we call also energy signal. This is also what we call a power signal. So this is non-harmonic signal or non-periodic signal. Okay, it doesn't repeat itself. All right. Okay, the next one is deterministic signal. Okay, when we say deterministic, it is the value is predictable. It can be defined. Okay, it can be determined. Okay, signal with a non-physical representation in either mathematical or graphical form. We can represent that signal with exact mathematical form. Okay, so it can be described by analytical expressions for all times, past, present, future. Okay, so hence the value is predictable for arbitrary times and can be reproduced identically arbitrarily often. Okay, it means that for example, like the sine signal. Okay, sine signal, sinusoidal signal, we can describe it in terms of sine or cosine. Okay, so you can actually predict the signal, okay, for the future or for the past, or the rectangle signal. Okay, for example, this signal. Okay, the wave or the signal is repeated at t duration. Okay, so basically you can describe the past signal, which is on the left. On the left is actually the future signal is on the left, and the past signal is on the right. So you can describe the signal clearly by using sine function, okay, or cosine function, okay, or cosine function, which is cos. All right. The value also can be represented, or we can know the shape, okay, or physical representation of the signal, okay, in either mathematical or graphical form. That is deterministic signal. But on the contrary, for the probabilistic signal, it has only probabilistic representation such as mean value, root mean square, and etc. It means that you represent that signal in terms of probabilistic. Okay, maybe you want to describe the signal in terms of mean value, okay, or you want to describe in terms of variance of the signal, or the maximum of the signal, or the minimum of the signal, and so on. Okay, it means that you describe the signal statistically or in probability. It is also known as random signal, and the value of the signal cannot be predicted accurately. For example, noise in communication system. So when we say noise, okay, it's something like this. It is very random. Okay, so how can you describe the signal? You cannot describe signal because you cannot determine the duration, because this signal is not repeatable. You cannot determine the duration. You can only calculate the average of the signal. Using integration, you can calculate the average of the signal, or you can only calculate the variance of the signal. Also using probabilistic, you can describe in terms of peak, maximum of the signal, or the minimum of the signal that it can go, okay, and so on. Okay, basically, you cannot describe in terms of non-physical representation, and you cannot predict. Okay, how can you predict the value here? How can you predict the value here? You cannot, because it's not the same. Okay, because it's not repeatable, it's not harmonic. All right. Okay, the next one is even signal, okay, and odd signals. Okay, for even signal, okay, even signal maksudnya inilah, okay, even lah. Okay, even it has the same value at time t and also at time negative t for all values of t. Okay, so let's say the value here, okay, which is at -1. This is only the example. For example, the value here is 1. Okay, and at 1, the value here is also 1 because it has the same amplitude. So the mathematical representation is ft is equal to f negative t. Okay, negative t here means -1, t here means 1. Okay, it is symmetrical at vertical axis. Okay, so dekat at y axis or dekat y here, okay, it is symmetrical, and we can also determine it if we actually fold. If this is a graph on a paper, so we fold two, okay, vertically at y axis, then it should be the same. Okay, this side and also this side. All right. So this is even signal. For the odd signal, okay, the value of odd signal at time t, let's say at time this time, let's say this is 2, okay, which is time t, this is the value of signal, is negative to the value at time negative t. So at time negative t, let's say this is -2, and the value here is 1, and the value here is -1. So the value of here is actually the negative of the value of here. So -1 is 1. Okay, so it is anti-symmetry at horizontal axis. Okay, so this is anti-symmetry at horizontal axis. This is symmetry at vertical axis. So this is the main difference between even signal and odd signal. Okay, the next one is skew signal. A signal can also be a skew symmetry, okay, if ft is equal to negative f plus minus t over 2 for any values of t. So this is an example. Okay, I think you can determine yourself the value here. Let's say this value, let's say this value, okay, at the peak here, okay, is actually the same as the value of this one, but the negative value of this, okay, at t plus t divided by 2. Okay. And finally, the last type of signal here is hidden odd signal. Hidden odd signal is odd signal combined with a DC value. Okay, So what does it mean by that? Is actually this is a DC. This is an original odd signal. Okay, odd signal which is anti-symmetry at horizontal axis. Okay, so when you combine with a DC signal, let's say this one has value of 1 and -1 at the peak. Let's say the DC value here is given as 2. So it means that you shift up the whole signal to the up direction. Okay, you shift up the whole signal by 2. Okay, so let's say this one is 2. So the new peak here would be 1 plus 2, which is 3. Okay, so this is what we call odd signal combined with the DC value. DC value means, okay, this is at let's say T. Okay, this is DC value, say F. So let's say DC value is given by 2. Just a flat signal, which has amplitude 2. So this one combined with the odd signal, it will become hidden odd signal. Okay, it means that this is actually the odd signal, but it's being shifted up by 2. Okay, so this is not anti-symmetry anymore, because anti-symmetry here, the value of this should be the same as this, or this one should be the same as this. Okay, this is anti-symmetry. But this one, the hidden odd value is not anti-symmetry anymore at horizontal axis due to upper or lower shift from the horizontal axis depending on the DC value. DC value can be negative, for example. So if this is negative, so the odd signal will be shifted down, okay, by the DC value. Okay, so this is what we call hidden odd signal. For part 1, I hope you can understand this part 1, or if you have any questions, so don't hesitate to ask me. Okay, thank you very much.